Yes, what?
I have heard that many kilometers below the surface of Mars is a frozen lake of some sort.
Yes.
Is there
Truth to that?
Is there truth to that?
There is truth to that. In fact, I'm not clear how they determine it, but I'm fairly clear that their methods are correct. They, I think they may have used measuring the gravity as they go over a particular crater on Mars, a particular section of Mars. They measure the lower density that is found close to the surface, and on the basis of that, of the movement of the spacecraft itself, they're able to tell that something different is going on besides solid rock. Water has a density of 1. Rock has a density between 3 and 5. So essentially water would be a void in a place where there should be rock. So they could tell whether there's water there. And so yes, and their estimate that there's liquid water is probably true because it's deep down, and by that, when you go deep enough down, the temperature inside the planet is such that water would be liquid, not solid.
It's warmer.
It's warmer as you go down. Yes. Do you have a question?
Even though there's no gravity or anything going on underneath Mars, is the water would still be liquid?
Even though there's no gravity going on underneath
Well, you know,
Mars.
like our Earth there's a lot of stuff going on in the center of our Earth.
There's lots of stuff going on in the center of our Earth. The same stuff that's going on in the center of our Earth is going on in the center of Mars.
Okay.
It's only a matter of degree, not weather. As you go down, it gets hotter. Period.
Okay.
And in fact, they have a probe on Mars, which is going to be doing a really cool thing. It's sitting on the surface of Mars. It's called the InSight lander. It doesn't rove around. It has 2 tasks, basically. One of them is drill down as deep as they can go into the surface of Mars, then measure the temperature down there and see how that temperature changes as it goes upwards, and see how much heat is coming out of the hole. So literally, I think they're going to flush the hole with something cold and then wait for it to heat up again. And they will literally know the rate of heat coming out of the planet. That's one of the 2 questions that is being asked by $500 million rover sitting on the planet. And the other question that's being answered by that same InSight rover is, tell me about Marsquakes. Marsquakes will reveal the structure of the rock beneath the surface. So they're essentially looking down to see what's cooking on Mars, and they're doing that work right now. So the answers haven't come back yet.
So what will that tell us?
They'll tell us what Mars is made of. You want to know
What potential?
you want to know the heat flow out,
Right.
because that'll tell you essentially how Mars is constructed from top to bottom, and the seismology will tell you how Mars is constructed from top to bottom. We know how the Earth is constructed. We know what it's like down, 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 all the way to the bottom, all the way to the center. To know the same thing about Mars would be 2 planets when we only have 1, and so it's like 2 gives you a straight line, and 1 tells you nothing about planets in general. So we will learn about planets in general from looking at Mars, that Mars InSight lander. The topic that I practiced for today was for TRT World. They interviewed me, and they interviewed me about the Opportunity rover, which recently died on the surface of Mars. So as a result of having studied up on it, I know a lot about it today. And having studied up on it, I have to tell you, there are some rather interesting and impressive things that little plucky rover managed to pull off in its 15-year history. 15 years of wandering under human control the surface of Mars, doing in 15 years science that had been programmed for it to be done in 90 days. So it did the 90-day program that it was programmed to do, insisted to be done, but it did it over and over and over again in different places to get different answers to the same question. What is Mars like? Was there ever water on the surface of Mars? Not the question whether there was ever life on Mars, because that rover couldn't tell if something walked across its feet, or in fact it could only tell if there was life on Mars if something walked across its feet. Otherwise it wouldn't have been able to tell. So it was not programmed to look for carbon-based life forms or even for carbon-based anything. It was programmed to look for water. And let me put something on the screen. So so this is a picture which, if you're paying attention, you should realize is an impossible picture, because the rover is in the picture. It's not that the rover, it's not that the Opportunity has not taken its own picture, selfies they call it, and Opportunity has taken many selfies of itself. But those selfies look a little bit cramped because they have a funny angle, but all the pieces are in, it's not a good picture. This is a good picture because it's not taken by the rover, it's in fact created by an artist to simulate the lighting conditions, what it would be like sitting in this spot at that time, casting that shadow. Nevertheless, Opportunity was there, did that, and that's the kind of job that it was doing. In fact, in this occasion, the courageous pilots of that rover chose to put it inside a crater whose walls were steep and at quite a sharp angle. Yet they risked the rover to make these investigations because by putting the rover in this place, they were able to see this is a crater. And if you go inside the crater has had its walls lifted up by the explosion. So this represents a history in time. So this represents a history in time. The bedrock has been raised so that it can be viewed through the ages. So you can literally look and look and look and look and look to see each of these layers and see what the story is through time. And the story that this told, perhaps in this crater,
Can you move that?
Yeah.
Thank you.
okay, the story that this told, perhaps in this crater, was that, and I'm not necessarily saying they made this discovery in this crater, but they did discover this sort of thing in these sorts of craters. And what they discovered in these sorts of things was that there was water there. Not only was there water there was water here and here and here and here, and each one of those layers formed, many of them, in the presence of water, and some of them not in the presence of water. So you see, there was water, there wasn't water, there was water, there wasn't water. Well, you can also see, not in the picture, but in the data that they gathered, that there was less water here, more water here, more water here, and more water here. And why is that? Because it's deeper, it's shallower over there. So over time, there was more water on the surface and less water on the surface. So the water came and gone. The thing that's also interesting about this, though, is that none of this water is water you would ever think about drinking, because basically It was closer to sulfuric acid than it was to drinking water. When you hear about water on Mars, you are told that, they have water on Mars, so because life needs water, therefore, water on Mars implies that life could have existed on the surface, and that is absolutely true. Except when you ask the question a little more detailed, what kind of water was it? And the answer comes back sulfuric acid. You go, wait, I'm not convinced that life could have existed on the planet. Show me some water that wasn't made, some rocks that were not cooked in the presence of sulfuric acid. So let's see. I have these pictures, unfortunately, arranged not in the order that I would want to present them to you, but in the order that I thought was most important if they were going to project them on the behind me during my interview. So these pictures are not picked for the purposes of telling you about the science. These pictures were picked for the purposes of showing you really cool pictures. Okay? So these are really cool pictures of which I'm going to try to weave a story around. Okay? So we'll come back to the water question. Look at this is what Mars is like. It's just dunes, sand dunes after sand dunes after sand dunes. And that sand is very, very small grained, such that if you were busy walking on the surface of Mars, you would get that sand stuck in your spacesuit, and you don't want to come walking in after having spent a day on Mars with sand grains that are smaller than anything found on Earth, and try to brush that stuff off of you. You better never take that spacesuit inside. So that spacesuit stays on the outside when you come in. You literally get into your spacesuit backwards, okay, and then disconnect it from the spacecraft, and then you walk out. When you come back, you reconnect to the spacecraft, and then you back out of it. So you never get to the outside. You never touch the outside of your spacesuit because the sand is so sharp and small and capable of ripping through anything, including your lungs. Case of black lung tripled. This is a nice picture. I picked it because it's a nice picture. It shows it has the correct characteristics of a good composition for a picture. It has good foreground, some interesting stuff in the background, and off a mountain in the background. Okay, is there science here? I'm not so sure, but it's pretty, and that's the goal of this. When I hit something I can talk about in terms of science, I'll get back to you. You have a question.
What is the point of doing, I understand the heat thing, but what is the point of trying to develop such a hostile environment for Earth people to live on?
What is the point? I know you understand the heat thing, but what is the point of creating of having people live in such a hostile environment? Okay, but that is a great meta question, and I'm going to give you a couple of my answers. But really, you need to speak to NASA about that. Okay, but nevertheless, and I'm not a representative of NASA, so I can give you my own point of view. And the answer is there's not much of a point. Okay, but Elon Musk's point of view, which is taken up by a few scientists and a few visionaries, they feel that the human race is doomed on this planet. And so we need to colonize another planet in which perhaps we would have a chance of survival. That is a reason given, a compelling reason given for colonizing Mars. It's the idea that it's a good place to visit on your vacation, not so good. Not until they built Disney World there. And it would be good, by the way. Disney World on Mars would be good because the rides would be so much more terrifying, because they could build them so much higher, because the gravity is so much less, they could do crazy things to your body. And so Disney World on Mars, a definite plus. Vacation on Mars, basketball on Mars, a plus. Moon, not so good. 1/6 gravity, okay, is not good for playing basketball, but 1/4 gravity, much better, okay. I have no idea what the real idea is, but I do. My gut tells me that while the human race is going to wipe itself out, it's not going to wipe every one of us out. Just 7.2 billion people when there's 7.3 billion people left. So there'll be a 1 million people left on Earth to repopulate it, and they won't make the same mistakes. Mainly because they won't have any resources. We will have used up the oil, used up the steel and the iron in the ground, and these people will be left with nothing else but a socket to try to plug something into that doesn't work, and they'll have to start an agrarian society all over again with lands that are completely depleted. So they're going to have a hard time, and it may take them another 10,000 years to figure out how to come back again. But the human race isn't doomed. I don't think it's doomed. Even if we make the planet super hot, you can go live in Antarctica if you need to. There's always a way for us to survive as a species. So we don't have to go to Mars for that, to save the species. That's my answer. Yes?
The astronaut, I think it's Mark Kelly, or I don't know, one of the Kellys.
Yes.
Scott, who went, his body is so destroyed by...
But he was hanging out in outer space. So the astronaut whose body was destroyed doesn't count in this conversation, because that's the lesson. Do not go to outer space on vacation. Okay, do not do that. It's not a good idea. If you're going to go to outer space on vacation, you go to the International Space Station that Arthur C. Clarke designed for you in the movie 2001. When they have that, then you can go. Don't worry about losing any sort of body mass or anything else like that. Until there's a tourist industry that supports that, I suggest that you don't go. I'm not going to go, because for the same reason, it'll kill me. It'll kill you. So, but eventually people will do it.
Yeah, on the previous image that you showed, one side of the rocks were flat. And what would account for that?
What you were seeing is a cliff. Why is it?
No, you had individual rocks
With the
there.
black rocks?
Yeah, the black rocks. One
In the
side was...
beautiful picture.
Right.
Yes.
Not this one.
No, I know, but in fact, it was in pictures like this. In fact, the picture that I've shown you was taken, perhaps, of a rock face like this. Okay, so there was a cliff. Okay, and then the picture that you saw was of a rock face like that. And what you saw were plates. What you saw was horizontal stripes, which is sedimentary rock, and you saw plates as well that indicated there was a continuous sheet of the same material. Let me see if I can find that.
Yeah, no, it was on
boulders.
my left.
Or
You're
split
right.
boulders or something.
You know, black boulders.
Oh, the black boulder one?
Yeah.
Oh, the pretty one that
Pretty one,
Yeah,
uh-huh.
just the last one.
Okay. Hold on. This one?
Yeah.
Okay.
Yeah, so if you look,
Okay.
there, one side of some of them are completely flat.
You mean like there?
Well, there are some of the smaller ones.
Chipped off.
Okay. So I don't know the answer to that, but I know answers to that.
Yeah.
Okay. So answers to this include these could be rocks that have been thrown out of volcanoes, and so formed as a result of the volcanic process. These could be rocks that have been eroded by the wind. Okay, the wind blowing in a particular direction steadily over billions of years could erode a rock so that it had a sharp edge. Okay, that is definitely possible. And then there's the possibility of simply cleavage. You have an idea?
Split through temperature difference between day and night.
Split between temperature difference between day and night, but usually rocks split as a result of water in the rock, which causes freezing and melting and freezing and melting, and that's unlikely in this situation. So I would rule that one out. But interestingly, the rover died. One of its last dying breaths was it saw some rocks, let's say like this. I'm not exactly sure if they were this large or this large, but they were large. They were rocks with sharp edges, and that was okay, except the place they were looking was they were looking at a place called Perseverance Valley, the last place of Opportunity rover on before it died. And it was in Perseverance Valley, and it was looking at rocks with sharp edges. And the engineers said to themselves, the scientists said, there's something wrong with this picture, because this is supposed to be a river valley. And if this is a river valley, these edges should be rounded, not sharp. But they're sharp. Let's go down the river valley till we get to the bottom, and maybe that's where the rocks roll, and then we'll find smooth rocks at the bottom. Good idea. Let's go there. And then it died forever. Okay, so literally they didn't have an answer to the question that they last posed, which is why the rocks were sharp, which is what you're asking here, except I think this is a different suite of rocks, for sure. I think the ones that we're talking about were little pebbles.
I had thought volcanoes, the first answer, that's what I thought, but
Right. And some of the rocks have been placed where they are as a result of volcanic explosions that took place billions of years ago. And the stuff is still sitting on the surface of Mars. And Mars dust is eroding and can erode rock. Because look at all that dust. Where did that dust come from? The dust came from rocks, from eroding the rocks. Mars wasn't dusty to begin with. It was molten to begin with. And then stuff happened, and dust was eroded, and eventually more dust, and more dust erodes more dust, and so you get dust, which is why you get a dusty Mars.
thank you.
Yes?
Is it possible for life of a different kind to arise from methane or sulfuric acid?
Is it possible for life of a different kind to arise from methane or sulfuric acid? That is one that, if you ask that question and you say, let's talk about Titan, which has a methane atmosphere, and you say, well, isn't that possible? And I say to you, I don't think so, because methane isn't a very good solvent compared to water. And then you speak to NASA, and NASA says, but let's send a spacecraft there to check. Okay? So maybe my opinion isn't worth as much as NASA's. And maybe NASA just wants to go to Titan under any circumstance, and if they use the word life, they get a free ticket. So I'm going with, you get a free ticket to Titan if you use the word life in the same sentence.
Well, are any of those moons possibly able to produce life?
So again, Titan, I rule it out because it's not a good solvent. I also rule it out because the temperature is ridiculously low, so that if there was life of a sort we don't understand, might have originated on Titan, then I would offer you the fact that since the temperature is so low, the rate of evolution would be so slow that life would just be figuring out how to make two of itself from one of itself about now, 4 billion years later. Okay, so I would dismiss the chance of evolution on Mars, even if on Titan, even if the possibility that life could arise would be real. Okay. Secondly, sulfuric acid, that exists in the clouds of Venus. They're going to go looking in the clouds of Venus for life. Believe me, they will do that. And the fact that I say that that's insane has nothing to do with the fact that they won't go looking for it, because it'll fund the mission. And I would love to know what's going on in the clouds of Venus. And if I have to make up a story about life existing in the clouds of Venus, in the made of sulfuric acid, by all means, I'll go and say, well, we don't know. So, we don't know.
So there's no place,
It's not that there's no place in the solar system. There's plenty of other places that have briny oceans that we can go looking at. We can go looking at Enceladus. We can go at Europa. Even Ceres, which is even more near, has signs that there's water below the surface. There's so many places there's water below the surface. There's water below the surface on Mars. There could be stuff going on Mars. We haven't begun to look, literally. They didn't ask me any of these questions. These are good questions. Yes. Yeah. No, you were asking. No, you. Okay. You.
You've mentioned several times that there's a kind of life on Earth in the depths of the oceans that doesn't depend on the sun or doesn't. Can you just summarize what that is?
Okay. We have discovered life on the Earth that doesn't depend upon sunlight. Okay. And the interesting thing about that is when we went to Mars for the first time, looking for life, we had no idea that such things existed. We thought we needed sunlight in order to make life. And we've been exploring Mars, at some point they discovered life deep in the oceans, and which informs the conversation about Mars, because we know, everybody knows, everybody but the person who interviewed me asked the question, is there life on Mars? We don't know. We don't know. But if there is life on Mars, it's deep down, and possibly being active in the same way that life on the Earth is active, based upon an entirely different chemistry than the chemistry that we're used to. A chemistry that can be sulfur-based, a chemistry that's based upon heat being emitted from below rather than from above. No sunlight for the energy, just heat from the center of the planet being the energy source. And as far as what those mechanisms, what those bacteria, those first level organisms, what do they eat? It could be compounds created deep within the surface of the Earth. Although I have heard some people say, and I'm not sure, so I'm not an expert on this particular point, that the oxygenated material that floats down from the surface of the ocean is somehow necessary in that food chain. So I'm not completely convinced that you can do without the stuff that is in fact illuminated by the sun in order to feed the organisms that live down deep. I know there are organisms that live inside of rocks, that spend all their existence inside of rocks, that have lived for hundreds of thousands of years inside of rocks and are still alive. But that doesn't mean, to me, that they didn't start their life in an environment in which sunlight played a part. So I'm not 100% able to say that you can make life without sunlight, period, end of story. Evolve it from the beginning without sunlight. I don't know that that is a case that it's closed. Okay? All right, back to pretty pictures. Oh yeah, so I didn't describe this pretty picture. Is this the one? No, probably not. No, that's not the one. That's number 3. I like this pretty picture. I didn't get a chance to describe it. In this pretty picture, again, opportunity is resting on the surface of the outskirts of a crater called Victoria Crater, and you can see the it's actually perched there. Of course, this is not real. The picture that is taken here was taken by Opportunity, and a artist placed Opportunity on the crater with the appropriate shadow to make it look real. But it's not real. This is an impossible shot. Nevertheless, because let me show you what is real. Nope.
see what you put on Google. TV set. Victoria.
So here, in this picture, you saw opportunity on the surface of Mars. You saw it standing there in a simulated picture. You saw it standing right there. The reason you saw it standing right there is because it was standing right there. This is an actual picture of a piece of the crater, and that is a picture of opportunity. So the fact that they fudged it a little bit, they should be forgiven, because they're simply giving you a better way of understanding what was in fact true. The crater itself, let's see if we can have that. Yeah, so Victoria Crater itself is just beautiful. I mean, it is. So again, opportunity was there, and now you can see the whole crater. This is almost 3/4, almost half a mile in diameter, the same size more or less as the Meteor Crater in Arizona. But, and like Meteor Crater in Arizona, the bottom shows that it's been eroded, and this is sand dunes that sit at the bottom. Opportunity came here. It came here, and then, realizing that it wanted to go into the crater, it spent a year doing this, trying to find a way in. And finally, when it got here, it turned around and went back. This took it about a year to do. Then there was a sandstorm that lasted a few months. And the sandstorm was like the sandstorm that killed it. But this sandstorm never cut off all the electricity to the rover's wheels and to the internal electronics, so it was able to recover. And after it recovered, it made its way into the crater like this and drove around like this inside the crater. So it spent another year doing this until finally they decided to leave, because they had gotten everything that they needed to get from this crater. They spent 2 years there, on the 2 years of its 90-day mission.
How did they figure out all the contingencies?
How do they figure out all the contingencies?
Yeah.
Well, remember, the contingencies are the things they do before it takes off. Okay, and then how they solve the problems is now what they do for the living for the next 15 years. So, what is your question? Before or
How is it
after?
done mathematically, or how do they answer all the questions that they need to answer before they go?
Okay, so one of the how do they answer all the questions they need to answer before they go? One of the best ways of doing it. First of all, I am trained through an excessive amount of education to be able to, with very little extra help, jump into one of their programs and participate in the design and engineering of any piece of the spacecraft, because my education was sufficient that within, I'd start out as a lowly intern, but after 5 or 10 years I would know what I was doing and I would be able to do that. So I know what you do. First of all, you have your math. Okay, your math. Here's a structure. Okay, it's a triangle. Okay, this triangle can support a weight, my head, but only so much before my fingers bend and break. I can, with the help of equations, I can figure out exactly how much tension or compression there is in each of the members of this object. Okay, and I can calculate then, knowing the pressure, how much it can take before it will break. And because every object will break. So I design it so that this thing will not break under the predicted tensions and compressions that come along with it. So every one of those, if you look at spacecraft designs, they're made up of pieces that are each individually bolted together so that they can literally calculate how the forces are distributed around the thing. George Washington Bridge in Manhattan is a beautiful bridge, but it was built before computers, so they overbuilt it because they didn't know how much pressure and compression was going to be in any member, so they just eyeballed it. They said, let's make it bigger than we think it could possibly ever need to be. And it was. They were able to build the Martha Washington underneath it, and who knows, they could build another two underneath it for that matter too. Then came the Whitestone Bridge, and they overbuilt that. But you can look at the Whitestone, it goes quite a distance, but it's much thinner. And then when you look at the Throgs Neck, which was built even later than that, it's even thinner than that. Because they had computers by then, you know. But when I was in school, which is in 1961 to 1965, the computers were idiots. They couldn't do anything. So I can't imagine building even the George Washington Bridge at that time. They were building the George Washington Bridge, Martha Washington at that time, and I'm sure they didn't have any ability to do that. But now computers are used to simulate all these things. They do all these things in computer code before they ever build the thing. And then, after that, they test it. They test it in every possible way they can. For instance, but it's hard to build computer code for everything. The parachute that was used to lower the next rover to the surface of Mars, a rover called Curiosity, which is bigger than Opportunity. Opportunity is the size of a golf cart, and Curiosity is the size of a small SUV. Curiosity needed to be stopped by a parachute. They built the parachute, and it worked. But they built it in Earth's atmosphere, because they couldn't build it in Mars' atmosphere. They didn't make the wind tunnel blow Martian level air. They blew Earth level air. So they blew it at 1/5 or 1/10 the speed that Martian air would be hitting the parachute. Parachute worked the first time. They said, let's try it again. They upped the speed of the air. Parachute opened and completely disentangled itself. They couldn't figure it out. Math didn't help. Math didn't help at all. What they did is, they did it again. But this time, instead of a few cameras, they had more cameras on the thing than any experiment like that had ever had in history. Like, I don't know how many cameras, just every camera, running slow motion. And when they ran it slow motion, they found out that there was a split second in which this parachute went whoop instead of whoop. And it was only a split second, but it messed up the parachute. And they realized that split second on Mars, because of the difference of speed of the parachute, 10 times faster, would occupy a split second, and that event wouldn't occur. So while the mathematics couldn't prove it, the test showed that it was safe. And without trying to do the math, because the math for that is crazier than, I mean, I wouldn't want to be involved in even the conversation about the math of a parachute, because it's really too wonky. You know, easy triangles. I made a triangle for you to demonstrate. It's not a triangle. So they said, okay, we're going to take a risk. We're going to put this thing on Mars, even though the last time we tested it, it collapsed. Okay? So they know what they're doing. They test everything when they can. And sometimes they don't test things, and then things go wrong. And I can think of 2 times when they didn't test stuff, and it went horribly wrong, and they were able to fix it. One time when we sent a spacecraft to Titan, and it was going to take pictures. I think I've told you this before, so I'm not going to give you the whole detail. Sent a spacecraft to Titan, and some guy raised his hand and, excuse me, I think it's not going to communicate. And he was a lone wolf, a lone voice in the forest. And finally he got heard. Very last second, very last minute, he got heard. And they literally changed the orbit of the spacecraft to accommodate the fact that he said it isn't going to work the way you planned it. So they changed their plans. That was one thing they didn't test. And then, of course, the biggest one that everybody knows about is the Hubble Space Telescope. They didn't test it. They didn't test the mirror. They launched it with the wrong mirror. The mirror was badly designed because they didn't test it, because they didn't think they needed to, because they didn't have money for it. So you can screw up very easily. So they test everything they can. Yes.
Two questions. The picture of the crater,
Yes.
was that taken from space, or is that
That picture of this crater was taken from
so
space.
there's something orbiting Mars?
There's quite a few things orbiting Mars.
Okay.
Right.
Taking those type of pictures.
Right.
Second thing, it's not really a question, but don't they have, it is a question.
Yeah, okay.
Don't they have a model on Earth that they run the tests on first before they transmit?
The model on Earth that they run the tests on first. There is a duplicate spacecraft on the Earth, but they test the spacecraft itself. So they drop it,
Right.
they bounce it, they swing it, the actual spacecraft, to see if it breaks. They do it a few times. I'm sure they test the model first, okay? But in the end, they test the spacecraft.
But don't they do something with the model? Let's say they want it, the one on Mars, they want it from A to B. Don't they test it on
Okay,
Earth
so
first?
that's another question. How do you so there was a situation on Mars where, as you can see, there's sand dunes. Okay, and so if you are driving a Mars vehicle, you don't go through the sand dunes, but sometimes you have to. But you go, after a while, you get cocky and you go, I think I know what I'm doing. This sand dune looks good to me. I think I can make it over it. And basically, they get that right 99% of the time, except the 1% that they didn't. And they spent 4 months in the sand dune. And how did they get themselves out? Well, the duplicate on the planet Earth was placed in the same sand dune with the same consistency sand, and they tried to get it out. And you don't want to mess this one up because you only get one chance. You know, what do? Do you play the game that we all play in the snow? Is that a good idea? How to get out of a sand dune? Turns out that's not the way to get out of a sand dune. The way to get out of a sand dune is to run the thing in reverse and keep doing that. It took them 4 months to figure that out. But they used the other rover, the one on the ground, in order to test that. Okay? So yeah, they have all sorts of ways of doing it. And by the way, the spacecraft, people ask, well, what have we learned? You know, and I tell you, well, there's water on Mars. But what we've learned is stuff like this. If you're going to be driving over sand dunes, you better let the spacecraft itself make some decisions before it calls home. Because it's at minimum, it's 12 minutes round trip. At maximum, it's an hour and 20 minutes round trip. And the spacecraft is going through a sand dune and it's slipping, and it better be told, if you're slipping, stop and await further instructions. Okay? Or even if you're slipping, back out and go around and try that. Because otherwise, they'll be spending half a day telling it to stop, go back. So the instructions as to what it's supposed to do next in the event of this and that has to be programmed into the spacecraft. That makes it a robot. The spacecrafts that are being sent to Mars, the next one, the one that's on Mars right now, in terms of roving, they have that sort of set of instructions. You can't, if you're going to drive across Mars, you can't have it just drive a few feet every day, waiting for the instructor on Earth to say, turn left, turn right, you know, this. You say, you have the spacecraft go from here to there, and avoid the obstacles along the way. That's how it's being programmed. That's cool. And if you hit any dust, back out. Don't get stuck. That's what we've learned. We've learned how to do that. It's just beautiful. And the only way, so when human beings go to Mars, and and we sit on the surface of Mars, and we ask our robot caddy to deliver us a glass of orange juice, okay, you can believe that nobody's going to be driving that thing. It's going to go off, get the orange juice you need, and bring it back, and it's going to know how to drive itself, because with all the experience of driving robots on Mars, we know how to tell a robot how to go get something and come back, right? So, more pictures. I'm telling you, preparing for this interview, I learned a lot of stuff. Good stuff. This is a picture of berries, just berries. Would you like some blueberries? These are blueberries. That's the name of them. These are blueberries. These blueberries, of which there are millions, billions, gazillions lying on the surface of Mars. I should have shown you a picture that has millions of them in it instead of just a small number. These blueberries form in the presence of water and only in the presence of water. But as I learned when I was doing the research, it turns out that these blueberries, water, yes, certainly, but sulfuric water, sulfuric acid water. So yes, exciting, not that much, not exciting because the water is the wrong kind.
Berries or are they?
What?
How could they be real? They're not.
They're not. They're rocks. They're not blueberries. They're rocks. We just call them blueberries so that we can, describe them. Here's an actual picture of Opportunity taken as a shadow of itself.
Does it self-destruct?
Does what self-destruct?
Opportunity.
Does it self-destruct? No, it does not self-destruct. There's the Victoria crater again. No, it does not self-destruct. Why would it need to? If you want to know, I can give you an answer. That's Cape Verde again, false color, and it went down. It went down this route, went down there.
Wow.
It's like the Grand Canyon.
Yeah. Oh, and canyons on Mars are that's a pretty picture. Canyons on Mars are deeper than the Grand Canyon by a lot, 7 miles deep. So that'll be definitely a tourist attraction when the time comes.
Unfortunately, I won't make it.
You won't be there. Another picture of Mars, also chosen by me for its scenic value, not scientific. And there again is another one of these faked up pictures in which Opportunity sits in a picture that it itself took. Nevertheless, it gives you a sense of what it's like to be on the planet. Imagine, the planet is pretty flat, so this one is chosen for the fact that there are hills here. But if you're landing on Mars, you better land in a flat place, because otherwise you might land on a hill, and that would be good for your spacecraft, which would tip over. So Mars at best looks as good as this, but probably at worst looks much worse than this, and that's where the astronauts are going to land, where it's really ugly looking. Maybe not. Who knows? By then, Elon Musk might be exploring with these beautiful rockets, playing all sorts of games. Here's another one of those pictures of the crater wall.
That's actual.
Yeah, no, these are actual pictures.
Actual.
Actual pictures taken by. See, isn't that nice? Isn't that pretty? Okay, that's
How deep is that crater?
what.
How deep is it?
I'd say 500 meters, half a mile, less. I don't know. But
Do you have any pictures of the very deep ones?
Well, this is the very deep one. This is the crater that gets you the best crater view of any that they've taken. There are big, deeper craters, but here's one in which the illumination of that same picture changes over the course of a day. How long is a day on Mars? Anybody? Day on Mars is as long as it is about the same length as a day on the Earth. 24 hours and a couple extra minutes, that's a nice picture, isn't it? You could hang that one on your wall. 24 hours and a couple extra minutes. That sounds great, except if you happen to be working the rover and that's your job. Every day you get up 15 minutes later. Pretty soon you start missing dinner with your family. Pretty soon you're getting up in the middle of the night, right? So keeping Mars time can be very painful, and they know that. And so they have worked out their systems of how they compensate people, not just with money, but with somehow or other an understanding that it's difficult to keep up a life like that. More sand dunes. Sand dunes on Mars are very much like the sand dunes on Earth. Every sand dune on Mars you can find a sister of that sand dune on Earth. I remember, I'm choosing these pictures because otherwise every other picture isn't interesting. These are the ones that are supposed to get you going, yay!
Yay, and run in the other direction.
Right. So who exactly wants to go to Mars? You have to not be going for the scenery. See, there's some more scenery. I picked some scenery.
Are those blueberries or different?
No, these are probably that same outcropping that I showed you before, taken right over there. I have the feeling it's the same thing, just from a distance, putting that in context of the mountains from behind.
Rocks.
What?
The sharp edge rocks.
Sharp edge rocks. Right.
Also flat sides.
Right. Flat size, sharp edge rocks. Probably due to wind erosion. Yes.
Is there any particular reason that this rover lasted for so long, or was it just luck? Did they learn something from its
Yeah,
longevity?
the reason for it lasted so long is exactly contained in this picture. Can you see the reason in this picture? The answer to your question is in this picture.
It's flat and no obstacles?
No.
Somewhat.
What looks in this picture that doesn't belong in this
It's
picture?
like a thing.
Tracks.
Yeah, a thing. That's a dust devil.
Yeah. It
Okay.
didn't get hit.
So here's what happened. So it's interesting that you had the question you asked was answered at the same time that I brought up this question. So they knew that Opportunity and Spirit, which is the co-rover that they were both launched at the same time, landed within weeks of each other. They knew that they designed it for a 90-day mission. Why 90 days? Who says 90 days? Why would you go 90 days? Why would you not make it longer? The reason is because you can't make it longer, because you know that the solar panels are going to be covered with dust, because Mars is constantly blowing dust, and they knew that from other landers that they had. So they knew that after a certain period of time, the solar panels would be covered with dust, and they wouldn't be able to produce enough heat to operate the machinery, to keep the batteries charged, and to keep the things warm, things that needed to be kept from freezing to death and never waking up again. So this had to be kept clean, but they didn't attach a set of windshield wipers, and it wouldn't have been workable anyway, given the fact that the dust is so small and so scratchy. There would be no way to blow it. How do you blow it off? Well, what you do you get lucky, and you get these sand devils, these dust devils, and the dust devils come by like the remora fish that clean sharks' bellies. Like the remora fish, these dust devils clean the instrument panels of the spacecraft, and do it so reliably that instead of 90 days, you get 15 years out of it.
But do they steer towards those?
No,
or
there are just so
kind
many of them.
What are they?
They're just dust devils. Have you never seen a dust
No.
devil?
You mean like a tumbling tumbleweed?
Well, no. Have you ever been in the middle of something and all of a sudden you see a pile of garbage floating up in a sort of a spiral?
Like a mini tornado.
Like a mini tornado, but it's right next to you. And it doesn't look dangerous, but it's doing this, and it's picking up whatever it does, garbage or sand or whatever. Have you never seen one? Right. You haven't lived till you've seen one of them.
So this is different
Waiting
than a
for
dust storm. This is not a
Th-
dust storm.
this is not a
right?
dust
That's
storm.
not
This
what
is a
killed
dust
it.
devil.
Okay.
Right. And these dust devils were responsible for keeping Opportunity and Spirit clean. So the reason that we had the long wait after it went out of commission is so that it goes out of commission. They know it goes out of commission because there's dust on the instrument panel. They know that. But they also know that dust devil season is approaching. And if they wait long enough, maybe the dust devil will clear the solar panels and maybe Opportunity will come back to life. So they literally waited through the entire dust devil season before they announced it to be dead. You know. Yes.
What does the atmosphere of the surface of the Mars consist of?
The atmosphere of Mars consists of air pressure that you would find if you piled Mount Everest upon itself 3 times. And then you stood at the top of that mountain. That's the air pressure on the surface of Mars. Virtually no air. No air. Given that there's virtually no air, that's a dust devil. Okay? So clearly the dust devil is spinning not at 30 miles an hour like it does on the Earth, but more like 300 miles an hour, able to lift the dust off the ground, because it is obviously lifting dust, and clean the instrument panels, but with very little energy.
Are those real tracks?
Are these real tracks? These are the real tracks. We've really been to Mars. Those are really tracks. It's really. I mean, if you need to get emotional about it, as far as I'm concerned, the fact that those are our tracks on Mars.
Why is it a different color?
Well, many of these pictures have been altered by the colors. Sometimes are not necessarily real. They change the colors to protect the innocent and to give scientists more information about what they're seeing. Sometimes the colors are real, in which case they are often not as interesting as if they monkey with the colors a little bit to make them a little bit more interesting and exaggerated. So, and these pictures don't necessarily come with the level of exaggeration built, as part of the caption. So I don't know. I'm saying I'll go with that's real color. Given how much of Mars I've seen, that looks like pretty real. Yes.
How are the dust devils created?
How are dust devils created in the first place? I don't know the answer to that question. I mean, I could make up one, but I don't know the answer to that. It's uneven things, and suddenly there's. I'm not going to make it up, but same way as it happens on Earth. Yes, Elaine.
Could the atmosphere ever change for any reason?
The atmosphere of Mars changes all the time, okay, because there's summer and winter.
But
So-
I mean, could it ever get warm enough?
It could get warm enough so that human beings can do all the things that they want to do in fairy tales.
Right.
Yes, no. No. In fact, it has been said by somebody recently, not necessarily everybody, but just, a curmudgeon among the people out there, that if you literally do everything you can to get the stuff that's currently inside of Mars on the surface, the water, if you take all the water that's on Mars, and let's say, they say that that you could cover Mars to a depth of 35 feet in water. That's how much water that we know is on Mars. If you cover Mars to a depth of 35 feet, if you take all of that water and you put it all up into the atmosphere and you go, give me greenhouse, you don't get greenhouse. Okay? you don't get enough greenhouse because there's not enough atmosphere. So if you're going to create this imaginary world in which we're all going to be happy and live, you got to go dig. According to this curmudgeon, you got to dig deeper down. You got to get more stuff. You got to throw that up into the atmosphere as well. And when you get enough stuff to throw up in the atmosphere, maybe you can do that. But no simple terraforming methodology will do, according to this curmudgeon. I don't like it so much, but I like telling the story. Yes.
Isn't it possible that the water underneath Mars is as acidic as the rest of Mars is?
It is very possible that the water under Mars is acidic as the rest of Mars is. It is absolutely, it is my personal understanding that that's probably more true than it isn't true. Okay? And
It makes logic. I mean,
Right.
it makes sense, right?
Briny, even the water that they say is liquid
It's briny.
is briny. They don't say liquid, they say briny liquid, which means it's full of salts. Okay? Given that Mars has got these god-awful salts that can essentially dissolve and become sulfuric acid, I think that briny means briny sulfuric acid. Again, I think. But you don't want to say these things because basically they want to go to Mars.
Right.
They want to go to Mars.
We
and
don't want to discourage them.
we don't want to discourage them because basically, God bless them if they want to go to Mars. I'm all for it, right? It's exploring the solar system. They went to the Americas for the spice trade. Then they went for gold. Okay, they keep getting it wrong, and then we end up with another reason to do that. Tobacco, good reason, right? And eventually, Detroit starts selling cars around the world. It works out. You just don't know how it's going to work out.
I understand everything you said. It's very good that we can.
Yeah.
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 Why don't we- she'll bring me all the-
This is a picture which is not a good picture. But I'm going to still leave it on the screen because, okay. Those of you who can't see it, that would be everybody. Okay. But I can tell you a couple of things. There's better pictures than this. I just can't necessarily find it in the moment. Maybe I can. Hold on. I'll just give one more try. Yeah, that's better. Okay, same picture, better picture. Okay. So, 15 years. 15 years. Okay? They're labeled 2004, 2018. So, Opportunity lands in Eagle Crater. NASA calls it a hole-in-one because it landed inside of a crater. Rolled inside of a crater. Hole-in-one. Spends 4 years getting to, and before it leaves, Victoria Crater, which we just saw all those pictures of. Okay? Then they decide this rover is so plucky that we're going to go and do the insane thing. Rather than just have it just wander around here, let's take what is guaranteed to be 1, 2, 3, a 4-year drive across virtually uninteresting landscape so we can get to Endeavour Crater, which is clearly bigger than, that was Victoria Crater that I was showing you. Okay? That's Victoria. This is Endeavour. Okay? And they decide they want to go there. And they get there in 2012. And they're thrilled because in the 11th year of the 90-day mission, they discover drinkable water right here.
Wow.
How do you define drinkable?
Water that is, in fact, not acidic, and in fact, you could easily write the right pH.
The right pH.
The right pH, right.
On the surface.
not on the surface, was on the surface,
Oh, what?
was on the surface,
But
but disappeared billions of years ago, but was on the surface, laid out a layer of rock that can only be laid out, gypsum, in still in
neutral pH water.
neutral pH water,
Yike.
right? Gypsum is made up of a compound that if you pour sulfuric acid on it, it's plaster of Paris.
Right.
Okay,
Yes.
you pour sulfuric acid on plaster of
It
Paris,
disappears.
it disappears, right? You know that.
Yes.
You're a doctor, you know that, and so you
So they determined that gypsum
right
had to be lying in fresh water.
in fresh water. It's as simple as that. It's as simple as that. It took them 11 years to find evidence for fresh water that is in fact drinkable, that life could have originated in.
That's amazing.
Right? So imagine that they didn't, they just decided to hang around here. They would never have made that discovery. Right? So the fact that the opportunity, I mean, and imagine 4 years of boredom. Every scientist on the team went home, took another job, right?
But there, the rover is on the edge of the crater.
Right.
It could have fallen in.
Oh no, the crater is shallow and it doesn't.
Oh, shallow. It has I imagine it as being very deep.
Yeah, it's very deep, but on the other hand, it's very shallow. So it's really just a matter of trying to get up over the bumps, you know. And they didn't. The bumps were sufficiently steep that they didn't try to go through it. What they did do is they right around here they decided they were going to go in. They were going to go in because I told you there were the pebbles at the top were sharp, and it was at the edge of what they called a river valley. So they said, let's go down to the riverbed and see what's down there. And that's when the storm came, and that's when it all ended.
Oh my!
Right. But in the meantime, they went to they passed this spot on nondescript spot on Mars called currently Marathon Valley. Why do they call it Marathon Valley? Because the rover had driven further on the surface of Mars than an official marathon distance, 21 point something miles. It had driven further than that. I named it Marathon Valley, and as of today, they have the world's record for the furthest travel of any spacecraft across the surface of any planet ever. And when you think about the fact that the moon is you think about the fact that the moon is 250,000 miles away, and that's I don't know the number. I really don't know the number. Much further away. The fact that the driving record is for the Mars and not the moon. Now it's not going to be long before some hot rod nation decides to go bopping across the moon and sending back pictures and charging for it. You know, would you like to see the latest? Would you like to drive the lunar car? You know, $500 for 20 minutes. You know, there will be all sorts of rovers roving the moon. But for the time being, that Mars Opportunity rover that is now dead has the long distance record. That's insane. Yes.
So the Chinese one that just landed on the far side of the moon, we can expect it to be roving all over.
It could rove some distance, but I don't know enough about how good they could do. The one of the distance holders of roving on the surface of the moon is surprisingly a Russian Lunokhod that was launched within a year or two of the last landing of the men on the moon. And since that time, nobody's gone for a record. The Chinese have had 2 attempts that have not done so well. This is their new attempt. They could go for anything. They could realize I could just drive this thing flat out for a couple of days and beat that record. You know, because the difference is this: if you're going from A to B, and you have something that needs to be told every step of the way, go left, go right, go left, go right, and if you don't have that built into the brain of the robot, you have to keep sending that back and forth. the opportunity had that built into the brain, so it was able to do a little, and now it is able to do a lot more, and curiosity is able to do even more. I imagine the Lunicod that they have, not the Lunicod, but it's a different word.
Lemon, is it a lemon?
I'm not getting the word, but it's not Lunicod. Their rabbit, I think, is another word for it. Anyway, their rover, the travel time from the Earth to the Moon is like a half a second. So you can literally be on the Earth, and it bounces off a satellite, which really doesn't take much time. But you can literally be on the Earth, and you can say, drive to that rock, point to it, and it will drive to it. And then as soon as it gets there, you can go drive to that rock and go there. And so you can tell it where to go, and it will go there and steer it. You can literally steer the thing on the Earth. So there's no reason, if they're going for a distance record, that they can't go and beat this record. And maybe they'll do that in a short time. There's no reason not to do it. Anybody could have done it,
But they did it.
Well, we did it. We did the current record because nobody bothered to get in the race.
Don't we expect that the moon is much more homogeneous than Mars? In other words, Mars has a whole variety of stuff in it.
Right.
My sense is the moon is pretty much just a basic rock.
Please do that. Okay. The Mars is differentiated, meaning that it has an iron or even molten iron core. Okay, and so as you go up, the density increases, and there's differentiation in terms of the minerals that you find as you on your way up. I think the moon is somewhat differentiated, but the density of the moon and the density of Mars is different, because the moon is like they ripped off the crust of the Earth,
Right.
and just the crust of the Earth was reformed into the moon, so there would be less variation as you go down.
Right.
Whereas on Mars, it was created from the stuff in the solar system to begin with, so it would have the heavy molten iron stuff would be at the base.
And you could find something like gypsum on the surface of Mars because of the great variety of materials,
Right,
which doesn't exist on the moon.
right, and the fact that there's no water.
In fact, it's no.
Yes.
How deep is Endeavour crater?
Yeah. I don't know the answer to that. But the thing I do know is that Endeavour is a very old crater. You can see by the fact that the crater rim has been worn away. Okay, so while the crater was much deeper in the past, it's been filled in over the billions of years that it's been there. So while it might have been, let's say, a mile deep then, let's say it's a half a mile deep now, or less. These things are, the Earth is filled, the Earth is covered with craters. Everywhere you look, there's craters. Guess what? Everywhere you look, there's no craters, because they've been eroded away by, we have some very virulent erosion mechanisms, namely thunderstorms and rivers and the like. And so every crater that has existed on the Earth, and there were craters on the moon, just as many on the moon as there were on the Earth, all those craters have disappeared through erosion. Of course, on Mars, the erosion mechanism is wind and probably not water. Wind. High winds, low atmospheric pressure, billions of years. So I don't know how deep it is.
And no
Yes.
tectonic
sand.
plates.
The sand is the thing.
Fine sand is also eroding.
No, the sand is the eroding mechanism.
It's grinding everything.
Yeah, the sand is grinding everything down. Right. So I don't know the answer to how deep it is. But if you Wikipedia it, which I'm not going to do in this split second, you would know the answer to that. Yeah. I think we're done. I have to end at this time. Here's the business. There is no class the week after next week, which there will be a class. There will be no class from March 5th to April 15th. I think it's 5 or 6 weeks.
Next week.
But next week there's a class, and I want to remind you, while I'm away, I have purchased Carl Sagan's Cosmos series. Not the crap that I took off the TV, but the actual commercial version of Cosmos series, and that will be playing here in my absence while I'm away. So if you like, you can keep coming. This is, bring your lunch.
Who's the monitor?
Who's the person who runs this?
Danny?
The new guy. He will be, because all he has to do is press play, and that he is eminently qualified to
And
do.
it'll start at 12:30.
It will start at our normal time,
Yeah,
12:35.
12:35.
12:35. Okay. So we'll see you next week.
Thank you very much.
Enjoy yourself.
Okay, thank you very much.